So I put the QR code on the right top of my slide. So if you are interested in seeing some data samples or presentation file or poster, you can refer to this code. So this is the teaser. While you're shopping into the fashion mall, then people are actually collecting your data, like mobility data set. So some startup companies like Joey install their Wi-Fi sensor at the top of the store in order to collect where you are. So when you turn on the Wi-Fi, then you are automatically giving your location information to them, because when you're using your cell phone and turn on the Wi-Fi, you can see the list of Wi-Fi access points, right? So they also know that you are around here, the vicinity of the sensor. So they are doing retail bit analytics by providing a dashboard as well as some consultancy services. So those are some data-driven monitoring examples. The first example is the number of visitors throughout the day of 2017 May. And the next example is the outdoor traffic by hour. So you can see that people visit at the 6 or 7 o'clock is the peak time for the store. Okay, so we are lucky to access those kind of data sets. So sometimes in an academia, we decide our research topic after getting the data set. So we have visited the startup company who make a sensor and then discuss what kind of research topic that we can do in university. And in Korea, we cannot get the customers purchasing data set because we don't have any permission to get the data set, the purchase data set from the other company. So we only have the Wi-Fi signals indoor mobility data set. So what's important metric? Maybe we can see and we can find a customer revisit because the data set actually collects all the Wi-Fi MAC address in anonymized way. So by looking through the data set, we can know that people are visiting back to the exact store. So these are the related works. First, indoor tracking. Since we are dealing with an indoor data set, we search about some relative works. So these works are done in the interior design or museum. By looking at the visitor's location, you can measure the customer or visitor's interest inside the museum. And some museum, like Guggenheim Museum, they changed the display plan. However, those researches does not include any predictive analytics. So next turn, we search the data mining communities doing predictive analytics. The most popular research topic is about next location prediction, like POI prediction. And in last year KDD, you can find the customer lifetime value prediction in Amazon or online purchasing communities. And the third topic is a churn analysis. So some people would not like to purchase their product anymore. Then people are leaving to the online store. So many vendors are trying to predict customers' churn behavior in order to retain the customer. However, in those data sets are all usually on online data set. So we try to put some contribution by utilizing an offline data set with a revisit prediction. And the third, there are actually some studies related to revisit, but those are mostly done on marketing or tourism. And those researches are mainly done by questionnaires and considering some qualitative factors. So throughout this related works, we decided to research on customers' revisit using their mobility patterns. So revisit in offline market is very important. Since now more than 85% of retail purchases still happens online, it might decrease a little bit time by time. And however, the retaining customer in online or offline are very important. The studies from Harvard says that if the store gets 5% more retention rate, then the profit will increase from 25 to 95%, depends on the store. So these are some statistics from our data set. So the x-axis is the number of visits. Only 15% of the first-time visitors are revisited in our data set. And more than 70% of the whole visits comes from first-time visitors. However, if the number of visits are over 5, then the ratio of customers revisit is over than 50%, which means that if you make people come to your store more than 3 or 4 times, you get more benefit, right? So these are my research questions. When you have mobility patterns inside a certain store, and our research goal is to predict customer revisit or not. So how to predict customer revisit? We use a gradient boosting tree model with carefully designed features. We use XGBoost in our paper. So our contribution is more toward feature engineering. And the second research question is how much effect of customer mobility has on prediction performance. And we found out that our accuracy result improves by 5 to 12% compared to the lower bounds, the baselines. Now we are going to introduce our framework. The prediction framework is a typical supervised learning framework. So when you have a set of previous digits as train set, those train set consist of Wi-Fi signals. So using the strong signals, you can group those signals into the customer's visit. And we also utilize some weak signals, which can be considered as a noise. And we utilize the signal as a trajectory outside of the stores. And we define it as a customer's occurrence of the store. And using those visits and occurrences, we design several features, and we can also get a label of customers revisit or not. And when we have a new data set, then using the same processing technique, then we predict the new visit, like test data sets, revisit status. And here are some of our raw data set. So raw data set has 3 attributes: sensor, name, and the strength of the signals and timestamp. I'll show it later again. And these raw data sets are pre-processed into trajectory by using multi-level semantic meaning. So we generate a trajectory by just utilizing a sensor level area, and we also make a category level area such as fitting room or men's outfit, women's casual, underwear or something. And depending on the store, we can also divide it into gender level trajectories. And we also utilize the weak signals with very, very low signal in order to capture customers' behavior outside or around the store. And we found out that that's very, very effective. Here are the set of our features. You can find the details of our features in our paper like this. But we'll show some representative features. So let me introduce you some characteristics of our features. First is overall statistics, like how long did person spend inside the store and how many areas that he covered, and some other statistics like variance. And travel distance and speed and acceleration. Since we get the store's floor plan, we can see how fast the people are moving inside the store. And the area preference, depending on area preference. Some people might like certain part of the area in the store, and we make it quantitatively as a score or number. Okay. And entrance and exit pattern and heuristics. Some of you might think that customer will revisit when he visit the customer counter to pay some money. However, some other people might think that if we buy some stuff in the store, then they might not visit for next few months. So we developed some heuristic feature in order to capture the characteristic of the customers. And we also put the time of visit and upcoming event of certain store, and store accessibility, and the group movement. Like some people might visit the store by themselves, however, some people visit the store with their friends. And we can get the signal, we can get the data by using the Wi-Fi signals. So these are some correlation between feature value and the revisit rate. So first figure is about total dwell time. And each point means the 5% of whole user. So the top 5% of user group actually revisit 30% more than the below 5% of users who spend very short time in the store. And the second figure means that it's a coherency, which means the category level. Some people wanna spend like almost all of their time in certain area, like men's casual. And those groups are the customers who just walking around the store with an equal amount of time. And we found out that people who focus more on certain part of the store will not revisit in the store than the other customers who really like to walk around in the store. And next figure is about the gate, entrance gate that the customers use. People who use back gate have 15 or 20% more revisit rate compared to the customer who use front gate. So we assume that people who, we actually visit the store and look at the people's behavior, and people who use the back gate are very familiar to the store, so there are more higher probability to become a VIP customer. And the last figure is about the average inter-arrival time. We haven't used any user profile like doing this. We haven't used any user profile doing this research because we don't have any. So we have to use customers' mobility pattern outside of the store as an ad hoc information of users' address. So some people who work around the store might have a more frequent inter-arrival time than the customers who live far away from the store. And this is amazing that the people in the top 5% has more than 4 times larger average revisit rate than the customers who live very far away from the store. And this feature is a difference between the first-time visitors and all visitors' behavior. And first-time visitors are more prone to the special event, such as a sale, wholesale event. So a person who visited 1 month before the wholesale event might visit with 38% probability to revisit because there will be a sale after 1 month. But this behavioral difference is much bigger compared to the other visitors, which means that if you have an event, then you can have a chance to retain more first-time visitors, according to our data set. We use 7 flagship stores data collected from Seoul, and each data set has 7 months to 2.5 years long data time. And these are very big stores. One of the store have 2 million visit count throughout about 2 months. And those visits are all over 60 seconds. So people who spend more than 1 minute in the store. And the revisit rates varies between 11% to 48% depending on the data collection period and depending on the category of the store. Here's our prediction accuracy. We downsampled our data set into 1 by 1, so the binary prediction accuracy baseline is 50%. And interestingly, we achieve around 67 to 80% for all visitors, predicting their revisit. And we also achieve 64 to 72%, even though they don't have any historical data, which means a prediction for first-time visitors. And we also introduced the predictive power of feature group and a semantic level of our feature. And here we introduce the effectiveness of our mobility data set, mobility features. We compare our model with two baseline. First baseline is the only using the number of visits. Since the visit from VIP customers revisit more, and the first-time visitors revisit less, so we can use that feature as a simple baseline. And since our data set is finite, people who has a record during the earlier part of the data collection period might have higher chance to revisit. So we use that data, the date of the visit and the number of visits as the second baseline of our model. And you can see there's a significant performance improvement on the second plot and the third plot. And the next experiment, we changed the data collection period to find the right amount of data to study revisit. And for companies, you have to maintain sensors for securing enough profit. And here's the tendency of prediction accuracy by enlarging the data collection period. For all visitors experiment, the accuracy gradually increases because the number of regular customers are also increases. However, on first-time visitors, the accuracy increases depending on the store because there might have some change of floor plans of certain offline stores. And lastly, there's a robustness on missing customers. Some people might not turn on their Wi-Fi and it's also decreasing. And we found out that performance is almost similar when we use more than million-size digital data set and when we use around 10,000 data set. So for certain store, only 0.5% of the customers are needed to guarantee a certain amount of accuracy. So the good news that we are going to release some part of the data set for future revisit prediction research. And for practitioners, it's important to see some bias inside the data set. Since someone can turn on their Wi-Fi and turn off their Wi-Fi, you have to be worried of the measuring some metrics. Like this is the example of the probability of capturing two visitors at the same time, group customers. But inside our data set, we only capture 15% of whole customers are coming to the store by groups. However, when we do our field study, we can find out that more than half of the customers are actually visited the store, depending on the Wi-Fi turn-on rate. It's very important when you're dealing with the data set. So here's our conclusion. The research goal is to discover the relation between customer revisit and their mobility pattern. And we used the data captured in 7 stores, and we found on the findings are the prediction model using some handcraft features and predictive powers of each feature group. And the performance improvements by utilizing indoor trajectory. And we can also find the tendency of predictive power by varying the data collection period. And we also found out that our model is robust on missing data. Okay, thank you very much.
All right, questions?
Okay.
When you predict revisits, do you predict the time at which they revisit?
So in our paper, we did a regression task and a classification task.
So the Mac phones now, the Apple phones, have a feature of anonymization of the Mac ID.
Yes, yes.
Of the Mac ID. And So because of that, you may never see the same phone again.
For iPhone users, we cannot see the revisit because there's certain MAC randomization policies are adopted. So we remove all the iPhone users' data logs. We have an attribute for that.
So you remove them because
Yeah,
otherwise
we
you would
remove
consider
them.
as new visitors.
Yes.
One last question, if there are any.
If there's are not questions, then I'll show you our GitHub a little bit. So we actually uploaded some small tiny data set, and so these are the data set, how it looks like: visit ID and revisit interval and a revisit intention. And each visit IDs are composed of certain. I'm really sorry. Just 1 minute. Okay. So these are the training data set, has a visit ID and a revisit interval with numbers and a revisit intention binary. And each visit ID is composed of indices. So these are the trajectories. And we can also see the details of each loss, such as timestamp and customer's ID and the name of the area and actual dwell time. So this is a minimal data set to do a revisit research. And we also put some statistics and a very baseline to conduct this research on our GitHub page. Okay, thank you.